Hi, my name is Sujata Krishna. I'm a lecturer in physics. I'm going to talk about my PHY2004 course, which is the Applied Physics 1. And this course is taken by several non-majors. I was the instructor in fall 19, and this is my design team, consisted of Professor Darren Acosta, who recorded several of the videos that are used in the course, along with Dr. Sean Weatherford, who's a colleague of mine, who designed initial development of the course, along with Brian Schilling. I ran a pilot run of the course and then decided to improve the course, and I worked with Alison Haskell. I'm going to show you some of the things that we did as our instructional strategy, which is the category under which we won this award. In designing how to run this course, I was thinking mostly about the instructor-student interaction. So instructor presence in the course, and also student-student interaction, and then student content interaction. And every week I would post an email to the students and an announcement which clearly laid out all the expectations for that week. What they supposed to be working on, what was due, and any feedback, sort of alerting them that I have given them feedback on the graded material. In instructor presence, other things that I would highlight were a very active discussion board in which I was present several times a week, interacting with students. And they would post things about difficulties that they had with the homework or any other concepts in physics that they were not understanding. Student content interaction mostly happened through videos, which were high quality by Professor Acosta and Dr. Weatherford. I included a more diversity of instructors because I noticed that there were no women who were shown women physicists doing problem solving. And that is a real problem in physics, a real issue. So I made some videos of my own to ameliorate this. Student-student interaction typically happens again in the group problem solving and continually on the discussion board. There were discussion boards leading up to each exam. Here's an example of the active learning during a group work session. The problem students are told that there's a car going up a hill and they need to find the normal force here. So they have to think about that this is circular motion, and then they have a component of mg which is providing the centripetal force. So they need to take that away, and the rest of it will be balanced by a normal force. A rubric on which the group work was assessed. And actually for the correct answer, there are very few points. The majority of points go in for the reasonings, also for sketching a diagram accurately. It's required for most physics problems, and then manipulating any equations that they write. Group work submission for this particular question, it's graded out of 6 points. Very nice diagram, clearly labeled, and they have shown gravity acting downwards. They seem to have taken a component of the gravity. So they have calculated what happens in the radial direction. That's exactly the direction of the centripetal force. So they have the right idea, but then they didn't know whether to add or subtract that from the mg cosine theta. Yeah. So you can see some discussion that they're having in Zoom. This is a synchronous recorded session. The students are all talking to each other on the web, and you find the students are very actively engaged. You see that they're talking about, I wonder whether this should be negative or not. And they write it out first as an addition, they're solving it, and then they finally get to their correct answer. I have some comments here in the feedback, they're not visible. So that's the kind of process that you see when you do group work. You can see the student thinking and discussing with each other, and that gives the instructor a very good insight into where the students are stuck. It's often difficult for us to see the way, to view something the way they view it. It's really when you see them working through it that you get that insight. And so I found these extremely helpful in getting the students further along. More active learning parts of the course, and I just want to take you to the course now, and so I'm going to change the share. And here, this is the front page of the course, and it takes you to different videos. If you click on here, I'll just give you a brief glimpse. Inside every one module is typically 1 week. The objectives are laid out. These are the lectures, and then solved problems in each topic. And I wanted to show you the discussion board just to show you how active it is. So we have these discussion board modules 1 through 4, modules 4 through 7, 8 through 12, and so on. And in all of them, they're like 70, 80 discussions, postings. So it's a very active board. I will not read through this, but in the top one, you are seeing a student comment on the discussion board about how the physics here made them think about which materials they can use in different types of construction situations. And then in the lower one, there's a student talking about she did the problem earlier when the module was just hot, and then comes back to it to prepare for the exam, the final exam, and finds that she's now struggling to do the same question that she got earlier, and then brings it back up on the discussion board. So everybody gets to think about it one more time. I thought these were particularly good uses of the discussion board. These are some of the student comments from the evaluation at the end of semester. I'm not going to read through them, but essentially these are very, very positive. We got really high scores on this and are pleased with how the course worked out. The best part really came at the first day of semester this year in fall, when I received this following email, and this is part of the email from the student who was my student through 2004 and 2005 last year. And he says that he finished the course with me and then finds that he thinks about it, especially when he hears something, and here he's heard a program, probably on the radio or something, about the universe. And it jogs some of his physics learning, and he's trying to apply it and understand it. And he's still contacting me about it to ask some questions to further his understanding. And this just made my day. You can imagine how it set me up so well for the semester. I felt enthused that we are on the right track. If we have got students excited, non-physics students excited about physics, feeling that they have made it sufficiently their own to apply their learning to what they hear or see in the media around them, I could ask for not much more. Thank you.